Hello, in this video we're going to solve some different type of right triangles. So in all four of these I have a 30-degree angle, a 60-degree angle, and a 90-degree angle. So the Pythagorean theorem will come into play here. Now, we only have the information on one side, and the directions have asked us to find the missing side in each of these triangles. So the way I'm going to approach this, I'm going to reflect these triangles about the long leg. So this is the long leg right here. So when I do that, this is roughly what it looks like. And to do a reflection, that means that this is 30 degrees, here's my 60-degree angle, and this is 4. And now the type of triangle we have here changes as well. This is a now equilateral triangle. I have all three angles being 60 degrees because these two right here, 30 and 30, add together to make 60. So if I know that this base of the triangle, each one is 4, so the whole thing is 8, well, that means that each side of the triangle is 8. So I know two sides of the triangle. That now allows me to do the Pythagorean theorem to find the missing side. So doing the Pythagorean theorem, I have 4 squared plus my missing side, we'll call that b, so b squared equals 8 squared. 4 squared is 16. b plus b squared equals 64. When I subtract 16 over, b squared is going to be 48. And so when I square root both sides to get b alone, and I factor tree, I'll be able to get a 3 and a 16. And I know that 16 is a perfect square, so if I square root 3 and 16, I'm going to get 4 times the square root of 3. Okay, so I've solved all the sides in that triangle. Let's look at the triangle on the top right. I'll do the same approach here. I'm going to reflect over the long leg. There we go. So again, there's the 60, there's the 30, and this is the 10. Once again, it's an equilateral triangle, so I know that this whole side over here is 10, which means that each of these sides must be 5. And so once again, now we can use the Pythagorean theorem. 5 squared plus b squared equals 10 squared. 5 squared is 25 plus b squared equals 100. This means that b squared is 75, and when we square root both sides, 75 is going to break into 3 and 25. And so if I square root both the 3 and the 25, right, because b should equal 3 times 25 makes 75, 25 is a perfect square, I'm going to get 5 still times the square root of 3. And so once again, there is all three sides. Hopefully you might be noticing a pattern between the short leg and the long leg. Let's try the one on the bottom right now. So again, I'll do my reflection. Now, I don't know any of the big sides in the equilateral triangle for this. All I know is that the long leg in this right triangle was 6. So what I'm going to do is I'll call this side x, which means this piece is x, which means this piece is 2x. Because the whole thing together, x plus x, would make 2x. And let's do the Pythagorean theorem. So x squared plus 6 squared equals 2x squared. So note that all of 2 and x needs to be squared. And so we get x squared plus 36 equals 2 squared is 4. X squared is, of course, x squared. I'll subtract the x squared over, so 36 is equal to 3x squared. That means x squared is 12. When we break this down, this becomes 4 and 3, and I'll square root both of those, right? 4 times 3 makes 12, and I'm looking to figure out what's going to simplify out of the square root of 12. The square root of 4 is 2. Whoop, I'm putting that in the wrong spot. So the square root of 4 is 2 times the square root of 3. That was what x is equal to. 2 times the square root of 3. And then the hypotenuse on this was double that. So it's going to be 4 times the square root of 3. And so those are all three sides. 2 root 3, 6, and 4 root 3. In the triangle on the far right, we're going to have n as my short leg. And once again, I'll do my reflection. And so I know this is n, which makes this, each of these, 2n. And we can do the Pythagorean theorem to find the missing side. And this is going to get us our pattern for a 30, 60, 90. So we have n squared plus b squared equals 2n squared. And it's our goal to figure out what b is equal to. N squared plus b squared. The 2 squared makes 4. N squared is n squared. Just like before, I'll subtract the n squared over, so now b squared is equal to 3n squared. And so when I square root both sides, b ends up equaling, well, I can't do the square root of 3, but I can do the square root of n squared. Square root of n squared, they cancel each other and we get n, still multiplied by the square root of 3. So our big pattern here is that when we know what the short leg is, in this case it's n, the long leg is that times the square root of 3, and the hypotenuse is double whatever the short leg was. And so that can be a quick pattern that we can remember to deal with 30, 60, 90 right triangles. For now, we are done.